Hi everyone, it's Mrs. Kibler, and today's lesson is going to be on word problems. We're going to go through a few different types of word problems that you might see. You need your Unit 2 packet, and we are on page 13. So number 1, we're first going to talk about consecutive integer word problems. Think of consecutive as what is coming next continuously. So number 1, write 4 consecutive integers beginning with each of the given integers. So A, 7, next comes 8, then 9, and then 10. Not so bad, right? B, let's start on the negatives. So negative 5, the next that will follow will be negative 4, then negative 3, then negative 2. So what I want you to do, because we're going to get into variables or unknowns, I want you to think about what is happening. How are we getting from 7 to 8? What are we doing with those numbers? We're adding 1 to get from 7 to 8. To get from 8 to 9, we're adding 1 again. And to get from 9 to 10, we're adding 1 again. And this will continue to go on. Same thing with the negative numbers. Negative 5 to negative 4, you are adding 1. Negative 4 to negative 3, you're adding 1, and so on and so forth. This means that to get a next consecutive integer, you have to add 1, even if we don't know what that integer is. So if the integer is x, what do we need to do to get to the next integer? We need to add 1. This would make this next consecutive integer here x plus 1. Because we don't know what we're starting with, all we know is that we're starting with x, and to get to the next integer, it's x plus 1. Well, now what happens when we get to the next integer? Again, we have to add 1. So over here at the side, we have x plus 1, which will give us x plus 2. And then the next integer, what do you think it's going to be? X plus 3. This will work no matter what we start with. So for letter D, we start with 3x. To get to the next integer, we still have to add 1. So this is going to be 3x plus 1, 3x plus 2, and then 3x plus 3. Sometimes the word problems might ask you to find consecutive even integers, which is a little different than consecutive integers, but let's go through that. So if we start with 6, the next consecutive even integer is 8, and then we have 10, and then we have 12. On the other side of the number line in negative land, if we start at negative 8, our next consecutive even integer is negative 6, then negative 4, then negative 2. So I'm going to ask you to go through this same exercise. What's happening when we get from 6 to 8? How do we go from one even number to the next even number? We add 2. And as you can see, this continues. Every time we need a new even integer, we have to add 2. We have to skip over that odd to get to the even. Same thing over here, right? Negative 8 plus 2 is negative 6, and so on and so forth. So if we start with an unknown integer, the variable x, to get to the next consecutive even integer, we're going to add 2. To get to the next consecutive even integer after that, you don't need to write this. I'm just going to show you here. It's x plus 2 plus 2. This becomes x plus 4 when we combine our like terms. And what is going to be the next consecutive even integer after x plus 4? X plus 6. Each time we're adding 2. If we start with x plus 1, that's okay. We can do this. So we still, to get to the next even integer, we have to add 2. So right here, we're going to have x plus 1 plus 2, which is going to be x plus 3. To get to the next consecutive even integer, we're going to add 2 again, x plus 5 and x plus 7. Whatever we're starting with, we just add 2 to get the next even integer. What about odd? What about odd integers? Let's go through that exercise again. So if we start at 5, the next consecutive odd number is 7, 9, and then 11. -3. -1 would be the next consecutive odd integer. Then we have 1, and then we have 3. So what is happening? How are we getting from 5 to 7? We're adding 2. And again, we're skipping over, this time we're skipping over the next even integer and we're going to the next odd. So we're adding 2. We're going to continue to add 2 every time we want a new odd integer. Same thing is happening over here. We're adding 2 every time we go to a new odd number. The same is going to be true if we start with an unknown integer. If we want to find the next odd consecutive integer, if we start at x, an unknown, we're still going to have to add 2. Okay, this is going to be x plus 2, and then we're going to add 2 again, so we're going to get x plus 4. We're going to add 2 again, so we're going to get x plus 6. So let's look at letter D, y minus 2. So we are starting with y minus 2. To get to the next consecutive odd integer, it doesn't change how we're going to do that. We are still going to add 2 to get to the next consecutive odd integer. Well, y minus 2 plus 2, those cancel out, and we are going to be left with y for our next consecutive odd integer. To go on to the next odd integer, again, we still have to add 2. We're skipping over that even number and getting to the next odd, so this is going to be y plus 2. And when we add 2 again, we're going to get y plus 4. So now that we have all that background in our brains, let's try a word problem. Now, I know that back in 7th grade, we practiced these types of word problems, and there were 5 steps that you had to follow to make sure that you answered a word problem completely. So I'm just going to review those 5 steps right now. So the very first step will be to define your variable, and think about that as your let statement. The next thing you're going to do, once you have your variables, you're going to write an equation to help you solve the problem. Once you have an equation, of course we solve. After we solve, we always check to make sure our answer makes sense. And the very last step is to go back to the problem, read the question again, and write an answer in a complete sentence. So this is how we solved these types of equations in 7th grade. So we're going to do this again. Okay, so number 4, we're going to solve this algebraically. Find 3 consecutive integers whose sum is 48. And this is important here because sometimes it might say consecutive and sometimes it might say consecutive even or consecutive odd. And we know from up above that we have to treat those a little bit differently. So this is just consecutive all the way back at number 1 when we wrote down all our examples for finding consecutive integers. So very first, step 1, we're going to define our variable. We don't know what any of these are, so we're going to let x equal our first integer. Our second integer is going to be x plus 1. And our third integer is going to be x plus 2. Great, now we have defined our variables and we need to write an equation. So let's see what else we know. We know the sum of these three integers is going to be 48. So I'm going to take my first integer. So there's my first integer. And I'm going to add that to my second integer. And I'm going to add my third integer. I'm just labeling this so you know. There's a lot of x's here. So first, second, and third. Three integers, and when I add them all together, I'm going to get 48. First thing we're going to do is we're going to simplify on the left-hand side of the equation, combine all of our like terms. So this is going to give us 3x plus 3 is equal to 48. Now we can go ahead and solve this equation. I'm going to subtract 3 from both sides. That's going to give me 3x is equal to 45. Divide by 3 on both sides. I get x is equal to 15, which is great. That tells me my first integer. That means x plus 1 is equal to 16 and x plus 2 is equal to 17. Now we want to check this to make sure that we are correct. So let's just check our three integers here. So here's our check. Does 15 plus 16 plus 17, does that equal 48? In my calculator, I checked it and it sure does. 48 equals 48. Now we're going to answer the problem in a complete sentence. So all I'm going to do, it says find the three consecutive integers. I'm going to say the integers are 15, 16, and 17. Ooh. Now let's move on to number 5. Find two consecutive odd integers such that 4 times the larger is 29 more than 3 times the smaller. So let's just take this one step at a time. We're first going to define our variable. So we're going to let x equal our first integer or our smaller integer as it is referred to in this problem. Because they're consecutive odd integers, the next integer is going to be x plus 2. So let x plus 2 equal the larger integer. Now we need to go ahead and we need to create our equation. So let's start here. 4 times the larger. Well, we know that the larger integer is x plus 2. So 4 times x plus 2 would be 4 times the larger. Is going to be equal to 29 more than 3 times the smaller. So 29 more is you're going to add 29 to that. 3 times the smaller integer is 3x, and then you're going to add 29 to that to get to your equation. From here, we can go ahead and solve the equation. I'm going to distribute my 4, so this becomes 4x plus 8 is equal to 3x plus 29. I'm going to subtract 3x from both sides of the equation. It's going to give me x plus 8 is equal to 29. Subtract 8 from both sides, and that gives me x is equal to 21. Great. Now we got our smaller integer. Now we need to know what our larger integer is. So x plus 2 is going to equal 23. Let's just check to make sure that we have the right answers. So 4 times the larger, which is 23. Does that equal 20? Oops, I was rewriting that. We'll go back to how we did it before. 3 times the smaller plus 29. 4 times 23 is 92. 3 times 21 is 63. So does 92 equal 63 plus 29? It does check. So now all we have left is to write our sentence. So we can just answer the question. It says find the two consecutive odd integers. We can say the integers are 21 and 23. Now I want to talk about perimeter word problems. With perimeter word problems, when you think perimeter, I want you to think picture. I want you to draw a picture to help you solve these perimeter problems when you get them. So let's look at number 6. The perimeter of an isosceles triangle is 150 centimeters. One leg of the isosceles triangle is 5 more than half the length of the base of the triangle. Find the length of each side of the triangle. The other thing I do want to give you as a little tip here is sometimes when you read it the first time, it just sounds like a bunch of gobbledygook. So reading it a second and a third time is really going to help you understand what the heck they're asking here. So perimeter of an isosceles triangle. I am going to start by drawing an isosceles triangle. An isosceles triangle has two sides that are congruent and a base. So these would be my congruent sides right here. The next thing that I want you to think about when you are trying to define your variables is I want you to ask yourself, in this case, which side? Sometimes it's what do I know nothing about? So which side do I know nothing about? And that's going to help you start off defining your first variable. So let's see. One leg of the isosceles triangle is 5 more than half the length of the base. So guess what? We don't know much about one leg of the isosceles triangle, but we do know something. We know that it's 5 more than half the length of the base. So right here, we know nothing about the base. So we are going to let x equal the base of the triangle. So I'm going to label that base with an X. Now we can use that to figure out how to define our leg. So one leg is 5 more than half the length of the base. So 5 more is plus 5, and half the length of the base, we know the base now we're defining as X. So now we can define what the length is. Once you have that defined, I do want you to label this picture. We didn't draw this picture for nothing. So this is going to be 1/2 x plus 5. In an isosceles triangle, both the legs are the same. So this is going to be 1/2 x plus 5. Now we have a great picture to help us here. What else do we know? We know that the perimeter is 150 centimeters. The perimeter is the distance all the way around a shape, and to find the perimeter you add up all the sides. So that's exactly what we were going to do for our equation. So I am going to take my first side, my first leg, 1/2 x plus 5, and I'm going to add the other leg to that, 1/2 x plus 5. You could also write 2 times 1/2 x plus 5, because you know that there's 2 of them. Either way works. And then I'm going to add my base. So now I have all 3 sides, and I know when I add that up, it's going to equal 150 centimeters. So now I need to combine all my like terms on the left-hand side. I have a 1/2 an x, a 1/2 an x, and a whole x. That gives me 2 x's in total. Plus 5 is 10. And that's going to equal 150 centimeters. Now we can go ahead and solve. I'm going to subtract 10 on both sides. That's going to give me 2x is equal to 140 centimeters. I'm going to divide by 2 on both sides, and I find that x is equal to 70 centimeters. Great. We have x is equal to 70 centimeters. We can look right back up here. X was the base. X was the base. So now we know that this is 70 centimeters. We still need to figure out what the legs are. I'm running out of room a little bit here. So 1/2 x plus 5. 1/2 times 70 centimeters, because that's what x is, plus 5. That's going to give me 35 plus 5, 40 centimeters. So this side is 40 centimeters. This side is 40 centimeters. We're going to check. So does 40 centimeters plus 40 centimeters, this is my check, plus 70 centimeters, does that equal 150 centimeters? Well, 40 plus 40 is 80 centimeters, plus 70 centimeters does indeed equal 150, so we check here. Last but not least, I'm going to write my sentence. I have to move over here because I'm really running out of room. I'm not as organized as I should be. So the sides of the triangle are 40 centimeters, 40 centimeters, and 70 centimeters. I want you guys to try number 7 on your own. This is another perimeter problem and it's a rectangle. So don't forget to draw your rectangle and label everything there. And then the last type of problem that I want to go over with you is inequality word problems. We've been talking a lot about inequalities. Number 8, 6 more than twice a whole number is greater than 16. What is the least possible value of the number? So the very first thing that we're going to do is we're going to define our variable. And what is our unknown here? What do we know nothing about? So 6 more than twice a whole number. We don't know the whole number. And you can always clue in there on the question when it's saying what is the least possible value of the number. So it means we're looking for the number, so we can let x equal the whole number. Now let's talk about creating our equation. 6 more, so that's going to be, you're going to add 6 to that, twice the whole number. So twice the whole number would be 2x. 6 more than that would be plus 6. You can also write 2x plus 6, but I get in the habit of writing the variable and the coefficient first. Is greater than 16. Greater than 16. So there we have our inequality. We can go ahead and solve it. I'm going to subtract 6 from both sides. That's going to give me 2x is greater than 10. Divide by 2 on both sides. I get x is greater than 5. So now let's go back to the question, what is the least possible value of this number? The least possible value. Well, if x is greater than 5, can it be 5? Can't be 5. So what is the least possible value? What is the smallest whole number greater than 5? What is the smallest? Oh, that's really messy. Hold on. What is the smallest whole number greater than 5? This is what this is asking you. 6. It is 6. So the least possible value is 6. Let's look at number 9. Dan is paid $150 a week plus a $15 commission on each camera he sells. So commission is just based on number of sales. So every time he sells a camera, he gets $15. How many cameras must he sell to make at least $600 per week? So this question, what are they asking you? They're asking you to figure out how many cameras he sells. So you're going to let X equal the cameras that Dan sells. Let's work through all these words to figure out what our equation is. So he's paid $150 a week. So he gets $150 a week no matter what. So he gets $150. And to that, he's going to add $15 for every camera he sells. So that's $15 for every, we don't know how many cameras that is right now. So we're going to add 15 times the number of cameras that he sells. I just got done telling you that I put the variable first. This time I didn't. So he must make at least $600 a week. That means at least he needs to make greater than or equal to $600. I am going to subtract $150 from both sides. It's going to give me 15x is greater than or equal to $450. And I divide by 15 on both sides. Gives me x is greater than or equal to $30. When I check this one, I'm going to use something that is greater than 30. I'm just going to use 31. So let's just say Dan makes his $150. Then he gets $15 for 31 cameras. Is he going to make at least $600? Well, 15 times 31 is 465. Is that greater than or equal to $600? Well, this becomes 615. So yes, this is how I'm just checking to make sure that my answer is correct. So now I'm just going to answer the question in a sentence. So Dan must sell, and I'm going to use the same wording that's in the problem, at least, meaning he can sell more, 30 cameras. That's all for today. Hope you have a great day. Bye.